Good morning, welcome to new lecture. Today I will talk about position vector and displacement vector, and also I will talk about force vector directed along a line. Let's look at with position vector. Of course I defined position vector last session, but again position vectors. Position vectors is a fixed vector which locates a point in space relative to origin. For example, if we want to describe the location of point A in 3D space x, y, z coordinate, and unit vector in the x direction it is I, in the y direction it is j, and in the z direction it is k. Assume we have point A. The coordinate of the point A, it will be xa, ya, za. In that case, r, a, it is position vector because it is a fixed vector and it describes or locates point A in 3D space relative to origin O. If we have 2 points, for example, assume we have 2 points A and B in 3D space. So again we have x, y, z direction, I, j, k unit vector, and we have point A and we have point B. In that case, this is O, origin. RA will be position vector of point A. RB will be position vector for point B, and RAB will describe the location of point B respect to point A. We call RAB is kind of position vector, but we call it displacement vector, or even sometimes again they call it position vector. Let's see if the coordinate of point A, it is xa, ya, za, and the coordinate of point B in 3D space, it is xb, yb, zb. In that case, RA, or sometimes they show with ROA, it will be xai plus yaj plus zak. RB position vector for point B, or ROB, will be xbi plus ybj plus zbj. From vector addition here in this triangle, if we apply triangle rule, we know RA or ROA plus RAB, this vector plus this vector, RA plus RAB, is equal to RB, because it is one triangle, and if we use triangle rule for vector addition, we can write this RA plus RAB is equal to RB. From here, I can write RAB is equal to RB minus RA. If we represent RB and RA in Cartesian vector form like this in ijk component, I can write RAB will be equal to RB minus RA. So it will be xbi plus ybj plus zbk minus xai, let's say put inside of parentheses, plus yaj plus zak. So it will be coordinate of B minus coordinate of A. From here I can write for RAB, if I continue here, RAB will be equal to XB minus XAI plus YB minus YAJ plus ZB minus ZAK. This is about position vector. If I want to define unit vector in vector direction, for example, I want to define unit vector in the direction of the vector RAB. In that case, unit vector RAB will be equal to the position vector or displacement vector RAB divided by length or magnitude of that vector. We should be able to define unit vector in any direction, unit vector in vector direction. Why? You will see it will help us if we want to represent force in the Cartesian vector form. Let's look at to our next topic, which is very important and it has a lot of application in static in this course. Force vector. Force vector directed along a line. What does that mean? For example, assume we have wall. I attach or tie one rope or cable to one fixed point on this wall, such as point A. This is rope, and I pull this rope at point B. I pull this rope at point B and I apply force. The force, for example, magnitude, it is 20 pound. The magnitude of force, it is 20 pound. If I want to represent this force in Cartesian vector form, how I can do that? We know force is vector, and force vector here, it is along this rope AB, will be the magnitude of the force F times the unit vector in vector direction. Here our vector, it attaches, it is position vector, it attaches point A to point B. Here point B, it is my hand, point A, it is one fixed point on the wall, and I attach that rope to the wall and I pull using 20 pound, for example. In that case, I know the magnitude of the force, 20. I should define position vector AB divided by the magnitude of this position vector. So it will be equal to 20 times position vector RAB in Cartesian vector form. You saw it will be XB minus XA I plus YB minus YA J plus ZB minus ZA K divided by magnitude of that vector. Magnitude means length of that vector. It will be square root of XB minus XA squared plus yb minus ya squared plus zb minus za squared. So, using this unit vector in vector direction, we can represent force in Cartesian vector form. In real life, because we know the coordinate of point A and we know the coordinate of point B, so we can subtract coordinate of B minus coordinate of A, I, J, K, and we will find the length of the vector, and we will find the vector, force vector in Cartesian vector form. I think this is enough. Next session, I will start to solve some examples. Then I will assign you several problems. You will solve those problems. Of course, I will review those problems again, and I will solve those problems step by step. You can double check if you have any mistake, you can correct, or any part which is not clear, you can contact me and you can ask your questions. Thank you so much for watching this lecture. See you next session. Bye bye.